Imagine you are watching a pot of water, waiting for it to boil. Every second feels like a minute. Now, think about a wonderful evening with friends, where hours seem to vanish in a flash. Our sense of time is flexible, subjective, and deeply tied to our emotions and our focus. But what about the dog waiting patiently by the door for you to come home? Or the fly that seems to dodge your hand with impossible speed? Do they feel time like we do? In short, how do animals perceive the flow of existence? To even begin to answer this, we have to accept a fundamental challenge. We cannot ask them. We can't sit down with a chimpanzee or a dolphin and ask them about their memories of yesterday or their plans for tomorrow. Instead, we must become detectives, looking for clues in their biology, their behavior, and the very laws of physics that govern their lives. The search reveals something astonishing. The world is not perceived through a single universal clock. It turns out there are as many versions of time as there are species to experience it. To understand this, we first need to look at the speed of life itself. A key concept here is something called the critical flicker fusion frequency. It sounds complex, but it's essentially the frame rate of an animal's eyes, the speed at which its brain can process distinct flashes of light into a seamless, moving picture. For humanity, this rate is about 60 flashes per second. This is why a movie, typically projected at 24 frames per second, looks like smooth motion to us, but a computer monitor refreshing at 60 Hz or more looks stable and clear. But what if your frame rate was different? Imagine a housefly. With its tiny body and hyper-fast metabolism, its flicker fusion frequency is around 250 flashes per second, more than 4 times faster than ours. For a fly, our world is playing out in extreme slow motion. Your hand moving to swat it isn't a blur of motion. It's a lumbering, predictable threat, a giant continent of flesh moving through a thick, syrupy atmosphere, giving it ample time to calculate and escape. This is why they are so maddeningly difficult to hit. They are living life on fast forward, gathering far more information in any given second than we are. This principle, that smaller animals with faster metabolisms tend to perceive time at a finer, more high-resolution grain, holds true across the animal kingdom. Evidence suggests that dogs, with a frequency of around 80 Hz, see the world a bit faster than we do. This might explain why they seem so uninterested in what's on television. To them, the screen is likely a flickering, disjointed mess. On the other end of the spectrum, imagine a giant tortoise or a deep-sea leatherback turtle. These large, slow-metabolized creatures have a much lower flicker fusion frequency. For them, the world might appear to be sped up. Quick movements that we can easily track might be little more than a blur. They are living life in a broader, more sweeping timescale, where individual moments might be less important than the slow, inexorable turning of the sun and seasons. Essentially, an animal's size and the speed at which it burns energy dictate the very resolution at which it experiences reality. A single second of objective physical time is not a single second of subjective biological experience. This moment-to-moment perception, however, is only one piece of the puzzle. Animals don't just live in a series of high or low-resolution snapshots. They also experience the great cycles of the world, the rhythm of day and night, the ebb and flow of the tides, and the turning of the seasons. And for this, evolution has equipped them with something truly remarkable: internal clocks. The most famous of these is the circadian rhythm, from the Latin circa diem, meaning about a day. This is the 24-hour biological pacemaker that exists in nearly every form of life on Earth, from single-celled algae to humanity. This clock doesn't just tell an animal when to sleep and when to wake. It's a master conductor for the entire orchestra of the body, regulating hunger, hormone levels, body temperature, and cell repair. It's the reason a cat gets restless at dusk, when its predatory instincts peak. It's the reason a dog might trot to the kitchen at 5:59 p.m., knowing with uncanny precision that dinner is imminent. But is this just a response to external cues, like the setting sun or the sound of you opening the pantry? To find out, scientists have run experiments where they place animals in environments with no external time cues, no light, no scheduled feedings, no changes in temperature. And it turns out, the clocks keep ticking. A hamster in constant darkness will still run on its wheel at roughly the same 24-hour interval. A dog's internal schedule of hunger and rest will persist. This demonstrates that the clock is truly internal, a legacy of billions of years of evolution on a spinning planet. This internal timekeeper allows a species to anticipate events rather than just react to them, to prepare for the cold of night, the return of the tide, or the daily arrival of its primary food source. And these clocks operate on multiple scales. There are circannual rhythms that tell a bear when it's time to hibernate, or a bird when to begin its epic 1,000-mile migration. For creatures on the coast, a circadial clock governs their behavior in sync with the moon's pull. In short, an animal's body is a sophisticated clock, or rather, a collection of clocks, all ticking in harmony with the ancient, predictable rhythms of the cosmos. So, animals have a biological sense of the moment and a cyclical sense of the day or year. But what about the kind of time that feels most personal to us? What about the past? Do animals remember specific events, or are they just responding to learned associations? This question brings us to the difference between two types of memory. Semantic memory is knowing facts. A dog knows the command sit, or knows that the sound of a can opener means food. But episodic memory is different. It's mental time travel. It's the ability to re-experience a specific past event, complete with context. What happened, where it happened, and when it happened. For a long time, it was believed that only humans possess true episodic memory. But evidence is mounting that we are not alone. Consider the western scrub jay. These birds are prolific food hoarders, and they are very clever about it. In a now famous experiment, researchers allowed scrub jays to hide two types of food in a sandy tray: perishable waxworms and non-perishable peanuts. They were then prevented from accessing the tray for different lengths of time. If only a short time had passed, the birds would preferentially go for the tasty worms they had hidden. But if a long time, long enough for the worms to spoil, had passed, they would ignore the worm caches and go straight for the peanuts. This is incredible. To do this, the bird has to remember what it hid, worms and peanuts, where it hid them, the specific locations in the tray, and critically, when it hid them. It is using its memory of a past event to make a decision about the future, demonstrating a sophisticated, flexible understanding of time and decay. This isn't just instinct, it's a dynamic mental process. We now see evidence of this episodic-like memory in other species, from rats who can remember the order of a sequence of smells, to chimpanzees who can remember where and when a tool was last seen. These species are not trapped in an eternal present. Their past is a resource they can draw upon to inform their present actions. This naturally leads to the final, most profound question. If an animal can mentally travel into the past, can it also project itself into the future? Is planning for a time that has not yet come a uniquely human trait? Again, the evidence suggests it is not. The scrub jay choosing peanuts over spoiled worms is, in a way, planning its meal based on a future outcome. But there are even more striking examples. Consider the bonobo, one of our closest living relatives. In one study, a bonobo was taught how to use a tool to get a treat from a container. Later, it was led to a different room where the tool was lying on the floor, but the container was absent. The bonobo picked up the tool and carried it with him, anticipating that he would need it later when he returned to the room with the container. This wasn't for an immediate reward, it was foresight. It was taking a specific action in the present to prepare for a specific, imagined future. Even more dramatically, zookeepers at a Swedish zoo observed a male chimpanzee, Santino, who had a habit of throwing rocks at visitors. Before the zoo opened each morning, he would calmly tour his enclosure, gathering stones and pieces of concrete. He would then hide them in small piles on the side of the enclosure facing the public. Hours later, when the crowds arrived, he would retrieve his pre-stashed ammunition and launch his assault. This is not impulse. This is premeditated, cold, calculated planning for a future state of affairs. He was imagining a future event, the arrival of annoying visitors, and taking steps in the calm of the morning to prepare for it. So, what does this all mean? It means the old idea of animals living in a mindless, timeless present is almost certainly wrong. An animal's experience of time is a rich and complex tapestry, woven from the frantic, high-speed perception of a fly, the deep, cyclical wisdom of a migrating bird, and the thoughtful, planning mind of a primate. Each species is locked into a unique temporal bubble, dictated by its metabolism, its senses, and its cognitive abilities. They don't just experience time, they inhabit it in a way that is custom-built by evolution for their specific way of life. Ultimately, studying how animals perceive time doesn't just teach us about them, it teaches us about ourselves. It forces us to see our own consciousness, with its constant worrying about tomorrow and its nostalgic longing for yesterday, not as the default state of being, but as just one of countless ways to navigate the flow of existence. The world is filled with millions of species, each experiencing a different river of time, all flowing together within the same universe. And by trying to understand their reality, we can't help but see our own in a new and much more wondrous light. If you enjoy exploring these wondrous ideas, subscribe to see where our curiosity takes us next.